Okay, so use the binomial theorem to express this binomial here in the form a root 6 plus b root 5, where a and b are integers whose values are to be found. So a and b are going to be whole numbers, okay? They could be positive or they could be negative, okay? That's what integers are. Integers are positive and negative whole numbers. So we need to use the binomial expansion, right? So remember, with regards to that, we use Pascal's triangle, don't we? Now, because it's power 3, this could be quite nice. We start off with 1 at the top, then 1 and 1 here. And of course we'll have 1, 2, 1 here, and then 1, and then of course because the second number here is 3, that's where we stop. That adds up to 3 as well, and we've got 1 here. So our expansion, remember when it ever comes to binomial theorem, I always do a plus b first, okay? So in this case it'll be a plus b cubed we're going to work out, because this is power 3. So don't worry about the square roots yet, let's just go with a plus b as our standard result. They're not asking for us to write this out as standard result, but that's what I would always do, always write out the standard result first. So we've got a, okay, to the power 3. So remember, always start off with the first term there, to the highest power. Okay, the coefficient obviously is always 1 to begin with. B then to the lowest power, which would be 0, so I'm not going to write that, b to the 0, because that's just 1. Plus then, well, the second coefficient is 3. Remember then you start to reduce the a, so a cubed there, which means you've got a squared there, and increase the b's. So b0 there, b1 here. Plus then the next coefficient, which is 3. A's then, don't forget, a cubed there, a squared there, so you're reducing a, so it's a, and then b squared, you're increasing b's. Plus then at the end, well, the last coefficient is 1, a's to the power 0, so don't write it, b cubed. So there's your general sort of result there. So what we'll do then is we'll plug in our question. So in this case, a becomes root 6, b becomes negative root 5, yeah? Take account of the negative there, okay? So you put in root 6 cubed there, okay? Plus 3 root 6 there, squared for a squared. B then is minus root 5, plus 3 then a, which is root 6. B then is going to be minus root 5 and squared, of course. And at the end then b minus root 5 cubed. So we'll work this out. So remember now, root 6 cubed, okay, quite simply, maybe I can write it down here, is root 6 times root 6 times root 6. Yeah, which will be, remember you pair these, yeah, okay, so root 6 times root 6 is just 6, so it'd be 6 root 6, that will be. Here then, well, we know root 6 squared is root 6 times root 6 as I saw there, so that's just going to be 3, 6 there, and of course you've got minus root 5 in there. Plus then here 3 root 6, and then in that bracket then when you've got minus root 5 squared, well, you know when you square you times by itself, so minus root 5 times minus root 5, that's just going to be 5 and positive 5, yeah, because minus times a minus is a plus. And at the end there, well, similar situation to this, isn't it? You just have negative root 5 times negative root 5 times negative root 5, okay? Well, negative root 5 times negative root 5, there's a pair there, isn't it? Okay, so that just becomes 5, as we saw earlier, because essentially you're squaring, aren't you? Okay, so it becomes positive to start with, minus times a minus is positive, and root 5 times root 5 is 5, and then times it then by negative root 5, so you get negative then 5 root 5 there. So our next line then we get 6 root 6. Here then that will be 3 times 6 is 18. Put the minus in front to be minus 18 root 5. 3 times 5 then, okay, so multiply the whole numbers there. 3 times 5 is 15 root 6, and then at the end then minus 5 root 5. So this will equal to then, if I put my answer over here, it'll equal to, well, how many root 6s have we got? Well, we've got 6 root 6 plus 15 root 6 is 21 root 6. And then minus 18 minus 5 is minus 23 root 5. Okay, that's good. So that's part A answered. Part B then, okay, it says given that root 6 minus root 5 all cubed is approximately 0. Okay, so you put it in your calculator, you'll have a really small value, right? It is approximately 0. So we do the squiggly equals there to show us approximately. Use your answer to part A to find the approximate value for square root of 30. Okay, well, if we could say this is approximately equal to 0, then we can obviously put the expansion that we have, because remember now, they're equal, and that is equal to this. We can put that equal to 0. Okay. Okay, so I've written the quick squiggly equals to show us approximately 0. And I don't have to keep doing the squiggly equals, right? And on the next line, I just say equals. Okay, so I've got that. How on earth are we going to approximate square root of 30 here? Well, what you can do, if you take the minus 23 root 5 over to the other side, okay, and then what I want you to do is, because you realise these are multiplying here, they're multiplying, keep the roots on this side. So you've got square root of 6 here, take that square root of 5 over, and of course because you multiply, take it over and divide. And the same here, you've got 23 here, take, because you're timesing here, take the 21 over and divide. And you've got this here. Now what you can do is multiply top and bottom by root 5, yeah, just rationalise it. And if you do that, you get root 30 on the top there. On the bottom, you just get 5, don't you? Okay, so then all you've got to do then is, because you get root 30 there, 5 on the bottom, take the 5 up. Because you divide it by 5, take it up in times. And then you get, if I do that on my calculator, you get a fraction for square root of 30. Now, if I work that out just by pressing the SD button, it comes out to be 5.476, right? That's what that fraction here comes out to be. But if I actually try square root of 30 there, press equals, and press the SD, equals very similar, isn't it? Okay, so this is a decent approximation.